Hello friends, today we are going to discuss a topic named simulator, and we are going to see the specific implementation of simulator called REST API simulator, and these are the things that we are going to cover in this particular uh, conversation. So to start with an overview, what is simulator, why you need it, typical use cases, comparison and traits, more important aspects like why we need which type of simulator and all that. And at the last implementation, we are going to see the stateful simulator implementation. So to begin with, like why we need actually a simulator. So simulator you can define in simple terms are the software systems that mimic the actual software system. So you can imagine a payment gateway, you can imagine a bank, you can imagine a mobile operator, any of the services that these folks provide. For example, let's say there is a mobile operator which provides billing, right? As soon as you make a call and disconnect the call, the amount is being paid from your account, and these all are exposed with the help of some kind of REST API. Or a simple example, another one is a bank account where someone is account is getting debited and someone else account is getting credited. So all these are like type of systems in real world, but now imagine a scenario where you are acting as any type of wallet, right? Paytm, PhonePe, or any other type of wallets that you have, and now they utilize banking services to provide their own services to their own customers, right? But not all the time these banks or bank APIs that they do are available. At the same time, another aspect is like there is a cost involved. Right? Whenever you call an API from a bank, and let's say you want to certify your product that things are working fine, even in their testing environments, they charge you some amount. Right? So in order to avoid these type of cost and enable certain types of testing which is not possible with real API integration, simulators come into being, and that's what we are going to discuss. Right? Why you need it, right? I mean, I discussed in brief, like why you need a simulator. Right? Take a typical example, right? I mean, if you want to, for example, validate a network timeout, right? And now, in case of network timeout, you need to hit certain API endpoint which will result in API timeout. By means of API timeout, but what I mean is like, let's say if you expect a certain response from some kind of API in 10 milliseconds and it is not coming, right, then you go and timeout, right? But in real world scenarios, most of the time when these APIs adhere to certain performance guidelines, then they will return you with the SLA that you define, which is less than 10 milliseconds for that sake, right? But at the same time, on the client side, like taking a typical example again, you are a payment wallet provider and you want to ensure that debit and credit happens within 10 milliseconds, but I also have to make my system robust and validate that network timeout in such a way that if network timeout happens, my current state of system should be in consistent position. And now how you will do that, right? And that's where simulator comes handy, where you will run the request that is incoming, right, by any means, uh, to time it out, right? Where you will run it for, let's say, beyond 10 milliseconds, say for 1 minute. You introduce a delay, uh, explicit delay, to ensure that this network timeout happens. Um, Another scenario which we are going to cover in the actual implementation can be of the case, let's say there is a bank customer, right? And now this bank customer goes, or account of that bank customer goes through a cycle where it starts with provisioning, goes to activation, goes to suspension, followed by deletion or cancellation, right? Now, a given user, right, when we are testing or validating our system as a client, again, a typical payment wallet system, at that point of time, if I want to simulate this scenario to validate that my system, if I am a provider of this type of wallet systems, works the way I anticipate in a given scenario where this user goes through a state change, right? So if I go and do it with the help of bank APIs, it will be too cumbersome because I don't may not have direct access to those bank APIs that will give me the right data. They will do purging kind of scenarios where they will remove the data from their system every now and then. So at given point of time, it will be a long cycle before I can validate that my system is working fine. Despite I coded for it, but I can't certify that yeah, things are going to work the way I anticipate at given point of time. And this covers like my two typical use cases which I want to discuss where simulators are very important. We are going to see the comparison chart also to validate like why this works. Now I move forward and these are like two types of simulators which we want to discuss today. Um, Stateless and stateful. And by any chance, if you feel that you know all these and you want to move forward, you can go skip this session for let's say first 5 minutes and directly go and jump into the implementation phase, which we are going to discuss in some time. So to start with, like there are two types of simulators that we can imagine in real world, right? One is stateless, another one is stateful. Okay, take a typical example. Let's say if you send a request and that simulator returns a response, uh, that that response comes back, but simulator do not maintain a copy of that response. So next time you send the same request, a simulator creates a new response and send it back to you. So in these scenarios, the state is not managed, or simulator considers every request as a new request. Right now, imagine a scenario where let's say you want to create a customer on the target application, and then you want to retrieve that customer. So in that case, retrieval will not happen because the simulator itself is stateless in nature. So the previous request which is sent is already lost because there is no state maintained, right? Versus stateful simulator, again a typical scenario where customer is getting created on a target endpoint system and then you want to retrieve it. This simulator maintains some kind of pointer or a reference to the record that is being written, and at that point of time when you want it back, it gives you the copy that has been created earlier. We discuss about say the traits, right? I mean, so now if I go like what is like your ease of implementation versus in stateful and stateless, right? So of course, if you don't have to maintain a state, you have less problems to handle, and it is easy to implement, right? Similarly, in a stateful, yeah, moderate kind of implementation complexity we can think of, but beyond that, it both stateless and stateful, they have their own niche or requirement in the ecosystem in software development. Applications, typical applications replay static output, echovac input, whatever you send, you come back. You always return the same output irrespective of what request you are sending, right? So these are the typical application for stateless versus stateful. Different output for the same input, right? I mean, again, take a scenario where um, uh, a customer's account goes through cycle, right? Goes from provisioning to activation to suspension, right? So you send a request for the same customer ID and then it will return you back once it is provisioned, then second time it is active, third time it is suspended. So that way you can simulate various scenarios on your client side which is consuming the given APIs. Network timeout we discussed before. part of functional test. I mean, another important aspect, given the kind of testing each organization performs, it plays a very critical role where you run this functional test in cycle every fortnight, every day, every hour. These tests are run, and you want to ensure that your things are working and we are not introducing any regression, any new problems, or APIs is reachable. Everything, like, probably simulator can help you elevate that, right? Another thing which is not mentioned here we can talk about is, like, if there are 2 or 3 discrete systems you are communicating with, right? That's where simulator can also help. So let's say you have payment gateway, you have another billing system, and now you are acting as an intermediary. Your payment comes in, and then you post a billed amount as an invoice to the billing system, right? So in that case, let's say if payment gateway is not in your control, you can replace it with simulator and then post it to the billing system, which is in your control. So these are like the typical applications which we can put up during testing. Stateless, I felt, based on the experience, having limited usage, versus stateful, are having widespread need and ask. Integration testing, endpoint mocking, contract based development, all this can be part of, like, needs. Schema generated, stateless is easy. I'm saying schema generated, you can generate simulators based on the schema in JSON format or XML format and all that. Sometimes stateful can be generated. There are certain ready-made simulators which are in place. Sometimes they suffice your need, but many times they don't. So probably at given point of time in your, like, journey of software development, you are going to or bound to create your own simulator or modify the existing simulator that is available in an incremental development cycle. Restart preserves state. Another important point. So if you imagine any endpoint provider, irrespective when you call it, how you call it, it won't lose the state of the data that you preserve on that particular provider. Again, taking a typical example, once you create a customer on the bank's API, the customer will be there, irrespective whether you retrieve it tomorrow, day after tomorrow, or not. Right? So here, in case of a stateful simulator, it preserves the state, and depend, like, what kind of a state you maintain. If it is in memory, it will be uh, here till the restart happens, or if it is in the disk or file system or database, then this simulators can persist and retrieve the data even beyond the restarts. Moving next, let's go dive deep into the implementation. We covered the basic premise, like why we need it, what are the benefits, key benefits, why this makes sense in the real world, right? I mean, because we are doing everything for a purpose, not like just for the sake of like learning and forgetting, right? And that's where I'm coming from, the typical implementation in the real world, instead of just talking some kind of theory. Uh, Coming back to the implementation part, let's say, what is my purpose and, like, motivation, right? I mean, so probably some of the things we discussed, right? Duplicate request check, network timeout, handling two same subsequent requests, right? I mean, sometimes this is very confusing, right? Subsequent, consequent, and all that. So subsequent is like you replay the request one after another with the same, let's say, customer or a subscriber, and then you get a different response we talked in another scenario. Recycle, another typical scenario. Okay, take an example of a mobile operator who gives your mobile number to someone else once you stop using it, let's say 90 days hence or 120 days. So typical recycle scenario. Okay, it was against someone named, say, XYZ, and now UVW is using it. So probably these are like another typical use cases that we need it. We have used template and configuration driven approach to write simulator here, so that it can be extended, and, like, if you put up if you just focus on, like, my first slide, I talked about something called generic API simulator, and that there was a purpose for it because we want to create a simulator which is a baseline and applicable for more than one scenario per se, right? There is some prerequisite for the implementation part. I'm using Spring Boot. I mean, though language is irrelevant, but I'm using Spring Boot for implementing this generic simulator. Conceptual understanding of REST services, CRUD operations. Like CRUD is like create, read, update, delete. I mean, this for the users who are coming for the first time types. Uh, Tools which I am using: Eclipse, Spring Boot Initializer. You can go to the website initializer.spring.io and then you will get it. Postman. Postman is a REST API client, freely available. You can download it and use. Maven local installation. Perhaps this is important because we are using Maven as a build system to create our solution. So yeah, without much delay, let's go to the ID, and here is my implementation part. So I downloaded, okay, let me put here the typical uh, I say configuration that I have chosen from the Spring Boot Initializer app is like I have chosen Java version 2712 for Spring Boot, and then the default parameters you can give your name, but I have chosen default. Packaging type jar, Java 8, and then the dependencies I want to show you in the POM. So I have chosen in that POM Spring Boot starter, web, and then security, Lambok, that is for create, like avoiding inserting getters and setters in my classes. And then I have Tomcat. Probably eventually if you want to build it as a war file, deploy it in some other Tomcat instance, you can do that. And then test and security. We have not been focusing today on this test and security, but more on the actual implementation. Okay, so probably this is the demo application which is responsible for creating my uh, simulator app. This comes out of the box from Spring. I have not done anything here. Once you download your the jar or like zip folder, you expand it, open it in Eclipse, and then you will see empty package with demo application in place. I quickly created 2-3 things. One is like a controller. Controller is the first thing that is responsible for intercepting my request and then responding to the request that is sent by my user. So this is like how a typical post mapping looks like. So just before that, what we are trying to do as a simulator, like the typical use case. Postman, I will show you like how the end state looks like. So I have a bank as one of the entities which I'm integrating with, and it is having an entity called user. So here, simulator is the main primary application context, and then I kept it simulator so that we understand this is simulator, not the actual implementation. And then I have two things. One is context, which is say the main context, which says that what domain it belongs to, and then subcontext, the entity of that particular domain. So this is the typical example of REST API endpoint through which we can avail the services. So here this service is going to create a user for me, and these are the uh, attributes of a given user, which says that okay, it's having first name, last name, address, account type, and other things. Similarly, I have created another post request, and this is for mobile operator. Here the domain is mobile, and then there is a subscriber associated with it. It is also having first name, last name, address. Here account type is Postman instead of savings, and then area, and we don't need an address for that sake. I'm just assuming that we don't need an address, though we need it. And then we have ID. This is the client side ID, which we need to send to the server, and this is another typical example how integration happen between systems, because you need a way through which, if in case of disputes, identify your the, like payload on the target system, then they're looking for some kind of ID on the client side, right? Otherwise, it will be very difficult to map like, okay, which request this belongs to, that kind of scenario. So this is the end state. Similarly, this is a stateful simulator. Whatever you create, you can retrieve it with the help of the same subscriber ID and username. Similarly, you have uh, username and bank account, and you can retrieve again. So coming back here, this is the post mapping. This looks like context, subcontext. It produces application JSON, and what it actually do is like it forwards this request with the help of context, subcontext, and this is very important because this is generic in nature. You see that we are nowhere mentioning that this is a bank user or a mobile subscriber. Yeah. So the important aspect of it is like we want this simulator to be generic enough that can be like uh, intercepted and put up in any context that is applicable. So let's say if you have pharma, you have EVs, you have anything, right? So probably you will have entities and you are good to go and replicate this simulator on your side. So I have created a simulator service which is having an execute method. It takes 4 arguments: context, subcontext, input JSON that is incoming from the client, and then the type of method. Here it is post, so I have passed on the post method. And then in the simulator service, we have an application like call to the application.properties, and that's where the templating things come into place. I have just for the sake of simplicity used application.properties. You are free to use it any XML, any JSON outside of this. So you need to put a typical attention on this particular part. What we are doing here, we have divided this or like created a unique identifier for each of the context. So here it is bank, another context is mobile, uh, and then in case of bank, we have divided this into 3 things, and this all coming from the context and sub context during the lookup. So what we are doing here is like what are the input fields that are incoming, and then what will be my output template for a given incoming request. So this is like bank user post, and this is the typical template. Whatever you see in the capitalized letter are the ones that are going to be replaced with the actual values. One thing which is will come from the simulator is going to be the ID that is going to be generated by the simulator and not by the input request, and that is what will designate that this response is coming with the validation and creation from the service that we are calling instead of being just returning the actual raw request. So coming back here to simulator service, what we are doing here is like we are taking the input JSON, converting it to JSON not. We are retrieving the unique key corresponding to each request that comes in, and unique key plays an important role. What essentially, so you have this part. In this particular case, if you see this, you have subcontext and context as a unique key, and what does that mean is like you need to identify that this entity is having a unique identification mark if I want to go and look up on my target system. So case, what essentially it means that uh, the unique key for, let's say, for an example of bank is particularly uh, this one: first name, last name, and date of birth, which gives me the uniqueness identifier for this particular record. So if username, first name and last name and date of birth all match, I consider that this is a user which I can retrieve based upon, right? I mean, so primary key we have created based out of the input parameters, and this is the important concept because all my simulator service will rely on this uniqueness identifier to retrieve the state which we will preserve during our post calls. So coming back, what we do is first we retrieve the unique key identifier, which means like what all comprises of that particular record. So in case of banks, it is first name, last name, date of birth, while in case of mobile subscriber, it is just first name and last name. So each of the context will have its own unique key, and that's what we are trying to use. So post that, once the unique key is identified, we create the unique identifier key. We are maintaining a map which will store the records that we have seen so far or the users we have provisioned in that request scene map. And then at the same time, what we are going to do is like return request scene dot get key based on the key that is incoming as an input request. So at any point of time, if we see that this user is already provisioned and again this request is coming for reprovisioning or this request is coming for retrieval, we go and see from this map, and this is very important because this request scene is the one which is maintaining the state for us. Okay, and at that point of time it returns from here, and in case we want to provision the new one, what we do is like we go to our execute method, and this execute method is doing 2-3 things. One is like it identifies the context, and what I am saying mean by context is the top level context, whether it's a bank or a mobile, and then based on that it finds all the input fields corresponding to that particular context. So for example, for a post mapping of a mobile subscriber, these are my field identifiers, right? And these are my input fields. So you focus on line number 10 and 11, and these two lines together will be helping us to find or create a response to a given request. And as I move forward, if you see here, I'm just creating the keys and the corresponding part. So what we are doing here, again we are calling one more overridden execute method, and what it does is like it gets the input fields in JSON, and then iterate over it to get the data corresponding to it. It returns the response, only massaging the output that is coming in from the input, and then use this for creating the response. So in case of response output, we are juggling in and creating business logic, and this business logic will be the business logic that you will write for your own simulator. This is something which is not generic in nature. Each one of you will create your own depending on the use cases that you are trying to solve. So in this particular case, what we have is a mobile, and then the second one is a bank. And what we are doing here is like creating the UUID. And if you remember, we discussed about the typical status for our output field. So here, what we are doing is like we are creating a whitelisting of uh, two names for mobile subscriber, for example, Jennifer Atkinson and Roger Miller. Uh, and at any point of time, if someone returns or like calls Jennifer Atkinson or Roger Miller as an input, I will return the state of those accounts in a cyclic manner. So it will start from active, it will go to provision, uh, suspended, and then furthermore cancel. So probably this is how you can create the state of any particular user that is moving uh, through that particular state. At the same time, you can enable your client applications, for example the payment gateways or payment wallet applications, to test out the scenarios where a customer's record goes through different states. So in this particular case, that is active, then suspended, and then provision. Yeah, so that's pretty much we have right now. So pretty quickly, I will just show the demo of this particular thing, and then we say here we have Harry Potter, and this is for mobile subscriber postpaid, and that's how it looks like. I just change name to say Raji Potter, and then say we change the name, as these are the unique identifier, first name, last name, and date of birth. I change the name here also, 1990. I click on send. This is in debugger. I continue, 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 continue. Okay, let me mute. You see the output that Rajiv has been created, Rajiv Potter, and this is the unique ID corresponding to it. Now, if I use this unique ID to retrieve Rajiv, I should be able to do it with the help of get. And since I'm using mobile, I will use the mobile get request, passing in the subscriber ID. Okay, you see this, whatever we have posted is being returning, and now this simulator is enabling us to test out. One thing to note, many newest solutions simulators are coming out of the box, and if they satisfy your needs, you don't have to reinvent, but it is a good exercise to write down a simulator that will clarify many concepts for you when you're doing the integration with the external APIs. That's like personal experience, but yeah, choice up to you, like how you want to do it. Closing notes, I will go back to the presentation, and this you will find on the Git. I'm going to post this all to the Git repo pretty soon. So uh, these are some of the observations. We are not hard coding the context in the request mapping. I just want to call out explicitly, no context hard coding. So this simulator is generic in nature. You name it, your context will be part of the simulation. Context, when I'm saying context, is a domain, right? Okay, don't get confused. Context is very, very dynamic in nature. So request response is managed by configuration. Everything is part of configuration. Whatever is your request, whatever is your response, everything will become part of configuration. Minimal code, maximum usage of the configuration. Design can be adjusted to accommodate any domain. Stateful simulator allow you to mimic real world scenarios without dependencies on third parties. Very important aspect, because at any point of time, whenever now such a complex systems come within the company or within the ecosystem, you may have multiple systems which are integrating with each other, and you may need at one point of time some kind of mimicking behavior, and that's where simulators comes handy. Future work, I mean, you are open to add on here, add support for HTTPS, move the configuration to XML JSON, where each request response can be segregated, context level, expanding the reach. You can deploy more than one instance of a simulator. Now, let's say you want to employ this simulator to do your performance testing, right? Performance testing of the client, let me be more specific, and then you can create more than one instance. Like say if you are like limited by the number of requests that simulator can provide, you can create multiple instances of simulator deployed behind your API gateway. You can use containers as well, and then send your request, get the response. One word of caution: don't use memory based state management the way this application is using. You need to outsource or externalize the state management to the database, or use something like console, another good uh, uh, remote management based database, or key value lookup endpoint, uh, and then use it for your stateful needs. Yeah, that's pretty much for now, and hope to see you soon. Thank you.